Wonderful. So let's get to it, right? Let's think about how we're going to integrate what we might think of as social preferences, right? Preferences for how your actions conform or don't conform with the actions of your community into some of the decisions that we've cared about, right, and thought about. So to start out with, let's think about human capital acquisition, right? In other words, let's think about the amount of time someone's going to spend in school. And let's do so by essentially taking the Becker human capital model, a simple version of the Becker human capital model, and introducing desires for distinction, right? Desire to stand out from your peers, and desires for conformity, desires to match your peers into that model. Okay, so before we do this, right, let's start without any sort of social preferences. We might have something like U of H and Y equal to some diminishing function of H, right, human capital, and some constant function of Y, right? So H, human capital, and Y is physical. Right, so let's say 8h minus h squared, right, plus some function of y that's continuous, right, 2y. And we're going to have some budget constraint like h plus y has to equal k, right, or is less than or equal to some k. Sound good? So in this simple model, right, we know that your optimal choice of human capital is going to be where your MRS, which is going to be du dh over du dy, is equal to the slope of your budget constraint, which is 1 over 1, and where h plus k less than or equal to, or sorry, h plus y less than or equal to k. Right? So this is going to be, right, our MRS, it's going to be the derivative of this, which is going to be 8 minus 2h over the derivative with respect to y, which is 2 equal to 1, right? So we'll say 8 minus 2h equals 2. H has to equal 6 over 2, which is equal to 3, right? So our optimal choice of human capital is going to be to invest 3 in human capital, right? Say spend 3 years in school, and then take the rest of your resources and devote it to physical capital, right? Sound good? So far, just what we've done before. So the first thing I want to do is introduce into this model a desire for prestige. So we can think about this as introducing into this model some desire on your part to be a little bit more impressive, a little bit more educated than your peers, right? We can imagine that, you know, every year you have a big family reunion, your grandma gives up and praises the accomplishments of all of your cousins and siblings, right? And you prefer to be the one that gets the most praise, right? That's the most impressive of the members of your family. So we're going to add to this equation here, right, which is just so far just about your individual preferences, a component that has to do with your social preferences. I'll say minus 2 times h bar minus h. So what's this? 2 times h bar minus h is basically the effect of prestige This is essentially how embarrassed you're going to be or how proud you're going to be, right, if you're able to be more impressive or less impressive than your siblings and cousins, right? So h bar is going to be the average human capital, average age of, let's say, family or community, right? Your siblings or cousins. Therefore, h bar minus h is essentially how much less educated you are than the average. So if you've got an h lower than h bar, you are going to feel ashamed of yourself, right? You're going to have lower utility. If you've got h greater than h bar, you're going to feel pretty great about yourself. Does this make sense? Great. So how is this going to affect your optimal choices, right? Now that we have your individual preferences and your social preferences. Well, we can find your optimal choice of human capital in exactly the same way that we did before, right? When we just had the black part of this this equation by saying that we're going to find where your MRS in terms of H and Y is equal to the price ratio, right, which is 1/1, and then use our budget constraint. So we're going to say our MRS is still going to be du dh over du dy, right? But now du dh is going to have your individual component and it's going to have your social component, right? So we can think about du dh as being the derivative of this thing with respect to h, right? 8 minus 2h, just as before, but then plus the derivative of this part, right? So minus the derivative of 2 times h bar minus h with respect to h, which is just going to be minus -2, or, I'll do it blue, plus 2, right? What's happening here? This plus 2 is essentially representing the social pressure on you to be more educated than all of your siblings and all of your cousins. Great. How about the return to physical capital? Totally unaffected by all of this stuff, right? So it's still equal to 2. This whole thing is still equal to the price ratio, which is 1/1. So now we'll say 8 minus 2ah plus 2 is going to equal 2, right? 2h is going to equal 8 plus 2 minus 2. So h is going to equal 6 plus 1, or 6 plus 2 over 2, right? Sorry, I'm killing myself here. 6 plus 2 over 2, which is going to end up basically being the 3 that you had before, plus an additional 1, right? In other words, because of your attempts to achieve social distinction, you're going to end up spending an extra year in school beyond the year that you would have spent in school just on the basis of your own personal preferences, right? Just on the basis of things like how interesting you think school is, plus how much more you expect to earn as a result of getting a greater degree of education. This makes sense? Okay. Now, something I want to point out here is, let's think about how this is going to affect your utility. So, in the simplest version of this, let's imagine that you and your cousins and siblings all have exactly the same preferences, all have exactly the same consequences of school. In other words, your siblings are all solving exactly the same problem you are. So in that case, right, if everyone's the same, right, then we'd have an h bar equal to 4, right, because the average of a bunch of 4s is 4. And so, of course, 2 times h bar minus h is going to equal 0 when h equals 4. Right? In other words, these social consequences are going to push us towards more school, but the end result is that none of us feel particularly proud or particularly sad when our grandma gets up and tells us all how we're doing compared to our relatives, right? On the other hand, let's think about the rate of return for schooling, right? The rate of return, the UDH, right? Just thinking about your personal preferences, is 8 minus 2h, right? So that's going to be, when we have an h of 4, 8 minus 2 times 4 is 0. In other words, you're investing in human capital at this point, up until the point where the rate of return you get on an additional unit of human capital goes to nothing, right? Thinking just about your personal well-being. Whereas, of course, the UDY is still going to be 2. So, whereas when you invested in 3 units of human capital, right, you invested up until the rate of return on human capital was equal to 3, just like we said in the Becker model. Now you're going to keep going until the rate of return on human capital falls below the rate of return on physical capital, meaning that you and all of your cousins would be better off if instead of all trying to outdo each other, you all stopped when h was equal to 3, right? All of you decide to graduate from college and then get jobs instead of trying to go to grad school in order to be more impressive. This makes sense? Awesome. So this is illustrating a really important consequence of a lot of these models, which is that when people have social preferences, right, they care about their standing relative to other people, that means that each individual's decision has externalities on everyone else, right? Your decision to pursue more education puts pressure on all of your cousins, and causes them to pursue extra education as well, this can make everyone better off. It can also make everyone worse off. Wonderful. Okay, great. So that's what's going to happen, right, if everyone's trying to outdo each other, right? Everyone wants to be a little bit more highly educated than their friends and neighbors. But what would happen if instead of trying to outdo each other, people just had preferences for not being different, right? People saw some advantage, again, either psychological or practical, right, to being as close to everybody else as they can manage, right? You can think about this in a high school sense. You might be afraid that if you get more human capital than everyone else, right, you study harder in school, you're going to be a nerd, nobody's going to like you. On the other hand, if you get less human capital than everyone else, then you're going to be a loser and nobody's going to like you, right? So you're going to have some pressure to try to make yourself more similar to other people. We can think about this by adding to this model something very similar to what we just saw, except we can think about let's have it be minus 2 times the absolute value of h bar minus h. What does the absolute value of h bar minus h mean? It means that if your human capital is lower than the average, right, lower than everybody else's, then you're going to be unhappy, right? You're going to have a gap here between h bar and h. The wider that gap gets, the more sad you're going to be. But by the same token, if your human capital is larger than everybody else's, then the absolute value of h bar minus h becomes h minus h bar, right? The positive of this. So your human capital being higher than everyone else is also going to cause you disutility, right? So we've got, again, h bar, average human capital of friends. Let's say absolute value of h bar minus h is deviation from average. Right? Okay. So how is this going to affect your optimal decision? So I think to help us think through this, why don't we break this utility function up into a piecewise function, right? So we can think about these two situations separately. Right, the one situation where you're a nerd who has too much human capital relative to everyone else and feels bad about it. The other when you're a burnout, right? You don't have enough human capital relative to everyone else and you feel bad about that. Right, so let's say that our utility in terms of h and y is going to be a piecewise function. It's going to be 8h minus h squared plus 2y minus 2 times h bar minus h if h is less than h bar. Right? This is the situation where you're doing worse in school than your friends. You're embarrassed that you're not doing well enough in school. Right? On the other hand, we have the situation 8h minus h squared plus 2y minus 2 times h minus h bar. Right? This is the situation where h is greater than h bar, right? Where you're embarrassed about being such a nerd. And of course, there's a third situation that we could really stick on either one of these, right? Which is the situation where h is exactly equal to h bar, in which case you don't face any social penalty at all, right? You're not embarrassed about being too good in school. You're not embarrassed about being too bad in school. Okay. So what's the consequence of this? Well, the consequence of this is that if this is our utility function, our marginal rate of substitution is also going to have two pieces, right? Our MRS of h and y is going to be du dh over du dy, but du dh is going to depend on which of these two situations is true, right? So what's du dh going to be if h is less than or equal to h bar? Well, in that case, it's going to be the derivative of this thing, right? So it'll be 8 minus 2h minus the derivative of negative 2 times negative h, which is going to be positive 2, right? Exactly as it was before when we're trying to be prestigious. On the other hand, if we've got too much human capital relative to everyone else, right, we're embarrassed about being a nerd. If h is greater than h bar, then our derivatives are going to be 8 minus 2h minus 2, right? Because we're going to have minus 2 times positive h. Sorry, I'll do this in blue. Does this make sense? In other words, what happens is, if we're thinking about all of our possibilities, as long as our human capital is below h bar, as long as we're worse, we're getting less human capital than everyone else, we feel pressure to conform that pushes us to do more and more and more school. The moment we hit an average, right, the minute our human capital matches everyone else, our GPA is just as good as everyone else's GPA, our pressure to conform switches in the other direction, right? It reduces the benefit of getting additional human capital. And if we're right at h bar, then in some sense, our derivative of utility with respect to h is somewhere between these two things, or is both of these things at once, because there's one change in utility if we exceeded our current level of human capital, a different change in utility if we were less than our current human capital. This makes sense? So our MRS, of course, is just going to be each of these things divided by 2. Awesome. Okay. So how do we even begin to think about solving this problem when we have a weird MRS like this? Well, one way to think about this is to say, we know that in the equilibrium, if everybody's the same, right? Again, if we've got this problem where everyone has the same preferences, we know that h has to equal h bar, right? Because everyone's going to make the same choice. Since everyone's got the same choices, everyone makes the same choice, then that choice has to end up being the average choice. So another way to think about this problem, right, if we're trying to figure out h, is we can think about how low would h bar have to be, right? How low could h bar be before it's not worth it to conform anymore? Right, until people are willing to choose h above h bar, how high could h bar be before people aren't willing to conform and choose h below h bar? Everything between those bounds is an acceptable and valid equilibrium. So let's start with the first, right? What's the lowest h bar worth conforming to? Or, another way to think about this, right, what's the highest h bar not worth conforming to? So the way we can think about this is we can say, if we had some h bar so low, right, everybody else jumped off a bridge and you decide not to do it, right, so low that you're not willing to conform, then you would end up choosing h greater than h bar, right? If h bar is too low, then h has to be greater than h bar. In which case, right, our MRS would equal 4 minus h minus 1. This makes sense? So we would do what we've been doing, set our MRS equal to the price ratio, which is just equal to 1, right? And we would say h is going to equal 4 minus 1 minus 1, right? H is going to equal 2. In other words, if we had some level of h bar below 2, right? If h bar was less than 2, h would equal 2. If h bar was greater than 2, right, h would not be less than h bar. Or, I'm sorry, h would not be greater than h bar. Why am I saying that? So I'm saying that given that in order for H to be greater than H bar, you have to deal with the social stigma of being a nerd, right? It's only going to be worth it to invest in human capital up to a level of 2. You go beyond that, right? You go to your, a GPA of 2.1, say, you're going to find that the social pressure to reduce your GPA is going to make it not worth it to get the internal benefits, right? The non-social benefits of a higher GPA. This makes sense? So what this means is the lowest level of H bar, where people are going to say, nope, I'm going to go above that, is equal to 2. And an H bar equal to 2, people are willing to conform. So there's a couple really important consequences of this. One consequence is, let's imagine that school got slightly more important for people graduating from this high school, right? The return to education increased a little bit. We went from an 8 here to a 9. We might find that while that increased the ideal level of education, right, brought up the lowest level that people are willing to conform to, increased the highest level, if everyone was already at something like an H bar of 3, no one might respond whatsoever to the change in the external rewards of human capital, right? Because it wouldn't be worth changing their behavior in order to not conform, right? It wouldn't be worth not conforming in order to take advantage of the new opportunity. Same thing if the returns for human capital fell. So one consequence of this model is pretty significant social stability, right? Another consequence of this model is that we can't guarantee, in much the same way we talked about in the last case, we can't guarantee that people's decisions are going to be individually or collectively beneficial, right? If everyone decides to choose an H of 2, or everyone decides to choose an H of 4, each person will be worse off than if everyone chose an H of 3, but no individual person is going to have the power to shift that social equilibrium, right? No individual person is going to have a reason to deviate from the behavior of their peers and neighbors.